going to move on to our next presentation, which is Svein Hjelmtvedt, from CTO of Additive Manufacturing from Fieldnode, and Marco Linhart, he is Head of Additive Manufacturing at KSB. They're going to be discussing on-demand manufacturing, how that's revolutionizing industries, particularly with integration of digital inventories, supply chains, leading to, hopefully, increased efficiency and flexibility. So, when you're ready, please take the stage.
So, hello, my name is Marco Linhart and I'm in charge for additive manufacturing at KSB. Just a brief introduction, I think nobody of you know KSB. It's a pump and valve supplier with 13,000 people working worldwide in more than 100 countries. And we have a very broad product portfolio from very small pumps, perhaps you know it from heating at home, for water, wastewater, industrial, oil and gas, energy, mining and so on. And we also have a foundry, and in the foundry we have a division for additive manufacturing. What we do is additive manufacturing. Of course, we started like everybody else with printing prototypes, printing spare parts, but additive has so much more potential, like optimizing your parts, optimizing your products, or even designing parts who could only be done additively to improve your products. And I will guide you to some examples we did in the recent weeks. That's us. We have more than 20 years experience in powder bed fusion. Right now we have five machines, 2 EOS M404, 3 M290s from EOS, one with a kilowatt Enlight system and one with a kilowatt big spot system. We started with printing in 316L, but then switched to nickel base alloy like the Inconel 625, 718, alloy 59, and so on. And we have been the first company worldwide being qualified printing pressure containing parts, and also have done the DNV certification right now for Inconel 675, level 3 for impellers, but planning to extend the material range as well. Just as a rough estimation, we worked on 8 tons of powder last year. This is one of the examples we printed recently, so topic is obsolete parts. So we have a lot of pumps in the field. This is an RPH pump used in the oil and gas business, and it's from 1982, so a very old part, but it's still operating, everybody's happy, but they need a spare part. Customer asks for oil cooler that sits in the bearing and cools the oil, lubricating the bearings. And this formerly was done by casting, 2 parts made from gray cast, and the customer got an offer for the new part 6 months lead time, and he could not accept that. And so they asked, yeah, can you increase delivery time, please? And as usually, topics like this end up in our department, and we said, okay, yes, we could print that cast design, or perhaps we could improve it. So honestly speaking, this is not top-notch engineering, rocket science stuff, but as you can see, we reduced the weight from 8 to nearly 2 kilograms, improved the cooling performance because we have now more surface, we have a wake-free design, so no room for fouling. It's made from 316L because we cannot print gray cast, so that's an upgrade as well. And the customer was very happy because within 3 weeks we did the clarification, we did the redesign, delivered the part. Of course, you could have done more, but a friend of Pareto, so 80% success with the 20% effort. So I think that's a cool example of what you can do with additive. Not only deliver the part faster, but also giving it some advantage. Another challenge is just a few weeks ago, a critical timeline for impeller. So the nuclear power plant in Philipsburg had a problem with wastewater treatment, and they needed a set of impellers, so 2 ones. And this was sourced from an external foundry, and when it came to our warehouse, we had to decline the cast because the quality was worse. And the customer got very upset, and the next delivery slot for casting was just too far away. So again, they asked, yeah, what can you offer? And we started, okay, this was a very strange stainless steel material, which we cannot print, but we offered, okay, perhaps Inconel 625 does the trick for you. And then we started discussions with the guys from the nuclear power plant, with the TÜV, with the authorities, to prove that Inconel 625 is sufficient for the job, change the testing plan from cast to additive manufacturing, did the reverse engineering, so we only had a very old drawing to get 3D data, and print the parts with the customer and the TÜV, so they were at our plant and looked what we did within 16 hours, and then 4 weeks later we delivered the parts. So printing was just a very small section, a lot of paperwork in advance and a lot of testing, because that is critical application where you need a lot of destructive and non-destructive testing to get your parts delivered. That is also a cool example from a big oil and gas OEM in Norway. We produced 2 sets of impellers, so 14 impellers in total. They were formerly done from duplex steel, and they wanted to increase material performance, so we switched to Inconel 625 and printed these according DNV AMC level 3. 14 impellers, 400 millimeter diameter. That is quite big for our machines. And of course, also with a shorter lead time than sourcing cast material. And that is just an example. We don't only print spare parts, sondern, as mentioned, we also print parts increasing our product's performance. That is a magnetic coupled pump, so a pump in our portfolio, and that is meant to handle explosive, dangerous fluids like liquid gases, oil and gas products. And the big advantage is that you have a can here, so you have not one shaft and a mechanical seal. So it's actually a sealless pump, and the momentum is driven by a magnetic field. That means you have a can here, and in standard that's just a Hastelloy can with 1.5 millimeter thickness. And the problem is when the customer has metallic particles in his fluids, they will just collect up by this magnetic rotor on the inside, and then you have a so-called can opener. And after some revolutions, it makes plop, and your explosive, dangerous fluid is basically everywhere, and that's not a good thing. And that is why we designed a double-walled containment shroud. So basically, it's a containment shroud, and on the outer diameter, you have a lot of channels. They have 0.8 millimeter diameter, 0.3 millimeter wall thickness, and you draw a vacuum in these channels, and as soon as the inner or the outer rotor damages the channels or the inside, the vacuum will drop, the pump will remain safe, so you can shut it down safely, but you have no leakage. And the big benefit is the design of that structure reduces the eddy current losses due to the rotating magnetic field to a level of the standard design or even below. That means, of course, we save energy from the electric motor, but on the other hand, we don't heat up the fluid in the rotor chamber and avoid vaporizing fluids in the bearings, which is a big benefit. So, as a short conclusion, what we see as spare part demands are ramping up, especially for obsolete parts. And what we also see from the industry, that our partners don't want to buy a huge pile of spare parts when they buy the pump. Because right now they have the situation that when you need a spare part, you sometimes have to wait 6 to 8 months for this part, and nobody can wait 6 to 8 months to get a spare part. And this is why he orders so many parts and have them on stock, knowing that perhaps he will never need these parts. So it might happen that 40 years later, he scraps the pump and scraps new spare parts, and that's of course a lot of money wasted. You need the storage, you need to buy it, that's capital you cannot work with. And that is not necessary because with additive manufacturing, we have the opportunity to provide these parts on short notice. The challenge is the clarification in advance. So like you saw with the nuclear power plant example, it was 4 weeks of paperwork to get these parts printed within 16 hours. So if you clarify everything in advance, have 3D data available, have working plans available, have done support structures, process simulation, and have just one number ready for order, you can decrease delivery time even further. And that's called a subscription model, and I'm very happy to hand over to Sven, which is from Fieldnode, and introduce the possibilities you have with a Fieldnode platform, which is a transaction platform for exactly dealing spare parts in that manner. So, stage is yours.
We have sound. You hear me? Yeah. Good, good. So my name is Svein. I'm the CTO and co-founder in Fieldnode. I'm stepping in for Fieldnode since they are at the hotel with fever. Probably had a little bit too much fun this week. But I'll do my very best to take you through the concept of Fieldnode. So Fieldnode is the market leader within digital inventories, especially focused in the energy sector. Yeah, we're an all-in-one solution for digital spare part management, or we have a platform that's built up to support end users, OEMs, to streamline their workflow, to streamline their qualification routines, to provide spare parts on demand. So with the Fieldnode system, supply chains are transformed from sending parts over to shipping files instead and making them available on time for a more efficient and a more resilient future. So the core setup of the Fieldnode is that we are taking care of the business side of things. We have a quite unique setup for a commercial model. That's very important to incentivize all parties, so it sort of makes sense for them to do transactions over the platform. Yeah, we have a very nice setup for an efficient and scalable workflows that guides all the users through the process of setting up jobs, setting up orders, even qualification regimes, etc. That's quite valuable and sometimes a little bit of a hurdle for the industry to get on board on. And also we are focused a lot on an API-driven setup. That means that it's easy to integrate for the large end users that have quite intricate systems to handle their daily business. Yeah, and of course everything is as secure as it can be with the highest certification on data security. Yeah, key features on the platform. We have a marketplace for digital spare parts, so it's possible to search up spare parts that you need and place orders directly with an OEM like KSB has just presented. And we sort of facilitate that for sort of all levels, from the OEM to pure service bureaus and from the end user perspective. Yeah, we mentioned the workflows already. They're there to guide you through, to make it easy to set up test plans, inspection plans, etc. We have set up a standardized qualification regime that's already built in the platform. So it's an auditing process to be a supplier to the platform. It's basing it on the industry standards within the energy sector, the API 20S and the DNV B203. Very important to be compliant with that. Yeah, and of course, as I just mentioned, a strong focus on the data security. The system is approved for ISO 27000. Yeah. And this digital transformation, that's already happening. We have seen a strong focus on this in the industry over many years, and we're already seeing great value created over the platform. We're already reducing lead times and increasing the operability for the entities on the platform quite significantly, from several months down to weeks, and in some cases down to days. That increases the possibility for the large end users to be more operational in the sector that they are working in. Yeah, and I don't think there was too much more to add to that. So opening up for questions.
Thank you very much. Yeah, we can take some questions now if anybody would like the microphone. Or if not, we'll go to a short break before the next presentation. So how long have you guys been working together then? How long has this partnership been in place?
Half a year.
For us, we set up the Fieldnode system in 21. I think that's the first time the project has been going on. I'm not sure when when you and KSB were onboarded.
Yeah,
But,
so we joined basically half a year ago.
Yeah.
The first items are on the platform, and we're working together with the end users to test the process to provide the parts. That's happening right now.
Yeah, and we had great support from the end users. We're working with 8 or 9 of the really large ones in this industry, so that they all can state their opinions and sort of guide it, what makes sense for them to maintain and keep on that platform, which is very important that we facilitate that.
What do you find is the biggest pushback from the end users, if there is any, or are they very accepting of this new solution?
I think from the end user perspective, we find them very positive to this approach. It creates massive value when they can have reduced their inventory stocks and have digital spare parts instead, as long as we're able to facilitate the availability of parts. Of course, this changes a little bit of the business models, so I'm guessing it's a little bit more to think about on your side from the sub-suppliers and the OEMs. But at least from all the 30 plus actors that's on the platform today, it's only great feedback, and we have a lot of these excellent cases as KSB has demonstrated.
So I really appreciate the subscription model, where you can really clarify everything in advance to make sure that all the information and data is available when it comes to an order. And that is the important point, because otherwise you will lose a lot of time to clarify topics, and perhaps there is a risk to miscommunication, and perhaps in a hurry make mistakes, and so everything is clarified and you're ready to go.
Okay. Good stuff, gents. Thank you very much.
Welcome.